Assalamu alaikum students, this is your environment video. After downloading VS Code and MinGW, we will go in system variables portion. That is, from the window we will go in added system environment variables. Then we will click on environment variables. In environment variables for the user variables for ARC computers, you will click on path. In that you will add a new path, and here where we have installed our MinGW, in there we have a folder UCRT64, and in the bin folder we will copy that path, and we have to paste this path over here as I did, and we will press OK. This is the task being done for the user variables. We will do the same task for the system variables. We'll go in path and we will add new variable having the same path of UCRT64 bin, and then we will press OK. We are doing this because this may cause errors usually due to unavailability of the system variables. After that we will open the VS Code. We will then go in extensions. We will search C++, and then you will find C++ by Microsoft.com. So you have to install it. Meanwhile, VS Code is also suggesting that we will install extension pack. It's not as required, but I do it for the best practices. After the successful installation of all the extensions, better to restart the VS Code. Then we will write on the compiler g++/version and press enter. And now you are viewing on the screen the message telling that our compiler is successfully working. Okay, this is sample number 1 file where we have included two headers. One is for OpenMP and one is for standard input output. STDO have already been used by you all in printing in previous sessions, but in OpenMP you will get help in parallel programming. We have a small function where we are printing this line, and we are printing that this parallel region is being executed by this thread. We use Pragma to parallel execute it. Pragma basically creates the team of threads and help them to execute the task, and finally join them as already discussed in the theory of the lab. If you will not use this function Pragma, then all this work need to be done manually, which is difficult. Don't worry about the number of threads created because it all depends upon the processor of your system. In our system we have 6 cores, 12 threads, so you will find out 12 threads by default. To run the program you need to compile it. Obviously we will use the same syntax using G++, showing the compiler of the C++. -f OpenMP is telling that parallel execution is required. Then we will give the name of the file sample1 cpp, and -o is used to make it executable file with the name of the executable file as sample1. I'll click enter. Now you can observe that sample_1.exe file have been created. Now executable file will going to be run // with the name of that executable file. Now you can observe the output on the screen. As this processor had 12 threads, from 0 to 11 threads have been executed. Thank you. Okay, now this is the another program. We have same headers and same function. Here we are just changing the print statement, and we are telling that which thread is printing and how many number of threads are there out of which this thread is printing. And we are also defining the number of threads over here. Already discussed that by default there are 12 threads as per our number of cores and core per threads, but we are taking it as number of thread 10 forcefully. Similar code, but the output would be different. We will compile in the similar way. But this time I'm giving the file as sample2.cpp. And make sure you do not need to enter the full path if you're working in the same directory, so you can just write the name of the file. Now making the sample2 as executable. देखें यहाँ पे बन गया है. Now we are running a sample2.exe. And now you are viewing the output. Viewing the 10 threads from 0 to 9 as we have forcefully specified 10. Order of thread से परेशान होने की जरूरत नहीं है. जो thread पहले execute होगा वो पहले नंबर पे लिखा जा रहा है. Okay students? अच्छा जी, this is the last example. Here we have the same headers, but we have slightly changed the functions. Initially we have used OMP set dynamic. This dynamically adjusts the threads and then create the respective number of threads. If your processor is busy by default, then this function can reduce the created number of threads. So let's disable it so that we can create the threads by our own choice. In second, we have given it to create 16 number of threads. Okay. So we have two parallel blocks of Pragma in which we have used single line of the Pragma. What single will do, whatever the first created thread it will get, it will execute it while it will discard the remaining threads. So जो पहला parallel block है उसमें सिर्फ ये print होगा कि region A में कितने threads print हुए हैं and now it's obvious क्योंकि हम by default 16 ले रहे हैं, so obviously the answer of this would be 16. Similarly, in next parallel block we are giving the number of threads as 10, so now it will not use it as globally but it will use whatever the value provided. Here we are using the same single command जो कि सिर्फ एक थ्रेड को आउटपुट को प्रिंट करने देगी. So you are viewing that here 16 threads are creating but we are printing only one. Similarly, in region B 10 threads are creating but printing only one. So now we will run the similar way. Initially we will compile, so whatever the file output would be we will execute it. Now we got the output. You are viewing that parallel region A printing total number of threads 16. One print is showing that only one thread have printed this line. Similarly, region B have total number of threads as 10 and single line printing is telling that only one thread has printed this line. That's it.